morning, all of you. I am Mahima Saxena, Assistant Professor at Akgec Department in Computer Science. Today I'm going to present my lecture on relational model. Relational model basically is a part in DBMS. Relational model is a model which stores the data in tabular format in rows and columns. Relational model uses a collection of tables to represent both the data and the relationship among those data. Each table has multiple columns and multiple rows, and each column has a unique name. Tables are also known as relation. In a relational model, the relational model is an example of record-based model. Record-based models are so named because the database is structured in fixed format records of several types. Each table contains record of a particular type. Basically, we have a table. The data present in that table is in structured form, in some structured form related. Suppose example is the data of student. We have a table of student data. In that table, we have information related to student, like student name, student's father's name, student roll number, student's address, student's phone number, which course he or she enrolled in it, which subjects they have. These are the informations we have in that particular table. Now, each record type defines a fixed number of fields or attributes. The column of the table correspond to the attribute of record type. The relational model is the most widely used data model, and a vast majority of current database systems are based on the relational model. Now, the relational model represents how data is stored in a relational database. A relational data model consists of collection of tables, each of which assigned a unique name. Now consider a relational table named student, whose attributes are roll number, name, address, phone number, and age. Previously, I already mentioned that this table is related to students' information. Which roll number student have, what is the name of student, where is he or she located, what's the address, what's phone number, what's age, what are the courses, what are the subject, what are the extracurricular activities students are involved in it. This all the information I represented in a tabular form, and this format is known as relational data model. Now, what are the important terminologies in relational data model we used? First, attributes. Attributes are the properties that define an entity. For example, roll number, name, and address. Now we have different types of attributes: single valued attribute, multi-value attribute, and derived attribute. In single attribute, we have like the roll number. The attributes in single valued, we have the attribute roll number because each and every student has only one roll number, not more than one roll number. That's why roll number is assigned the category single value attribute. Next is name. Name is also a single value attribute, maybe sometimes multiple, because we have some peoples have nicknames also. But in age is a derived attribute, because from age, suppose we have a date of birth of any student, so we can derive what is the age of that particular student. This is called derived attribute. Multi-value attributes. Phone number is the example of multi-valued attribute, because any student or any person have more than one student number, phone number. This is called multi-value attribute. Now the next important terminology of relational data model is relational schema. A relational schema defines the structure of the relation and represents the name of the relation with its attribute. For example, student, we have a table student. Now in this table, we have different attributes that are represented in the form of columns, like roll number, name, address, phone, age. These are the attributes. And the relation schema, we write relation schema in this format, like student name of the table, and all the attributes separated by comma. This is called relational schema. Now, next important terminology is tuple. Each row in the tuple Each row in the relation is known as tuple. Every row in the relation is known as tuple. Next is relation instance. The set of tuples of a relation at a particular instance of time is called relation instance. Table 1 shows the relations instance of student at particular time can change where there is an insertion, deletion and updation in the database. Now, next important terminology is degree. The number of attributes in the relation is known as the degree of the relation. The student relation defines above has degree 5 because we have 5 attributes. That's why this is called the degree 5. Now, what is cardinality? The number of tuples in relation is known as cardinality. The student relation defined above as the cardinality 4. The column. Column represents the set of values for a particular attribute. The column roll number is extracted from the student. Null values. The null value which is known as not known or unavailable is called null values. It is represented by blank space. Example, phone number of student having roll number 4 is null. Suppose we have this table and roll number 4 named Suresh lives in Delhi. The entry of the phone number is blank. This is called the null value. Next is relation keys. This is the most important topic. The keys are very important. In next units and next video lectures, I will upload some more lectures on these particular keys. These helps us to solve the functional dependencies questions, etc. Now, what is relation key? These are basically the keys that are used to identify the row uniquely or also help in identifying tables. These are of following types. First of all, we have primary key, candidate key, super key, foreign key, alternate key, and composite key. These are the keys which we used in all types of models or in SQL queries also. Now, the first one is primary key. Primary key basically is a column of a table or set of column that helps to identify every record present in that table uniquely. There can be only one primary key in a table. Also, the primary key cannot have the same values repeating for any row. Every value of the primary key must be different with no repetitions. For example, first of all, I'll explain what is primary key. Primary key basically is a unique value that we used to identify a particular student. For example, we have a student and I want to identify that particular student. So, in a particular table, Aadhaar number is the unique number because maybe roll number is repeated because we have different branches in different subjects and different classes. But Aadhaar number will never be same for 2 students. That's why Aadhaar number is the example of primary key. Next is a primary key is the most significant one to understand what are keys and what is primary key in DBMS. The primary key constraints put on a column or a set of columns will not allow that have any null value or duplicate value. One table has only one primary key. This is the main point. This is the most important point that every table has only one primary key, and primary key is not null. Other keys are may or may not be null. I will explain later. But primary key is always one and not null. Values are present or duplicate values are not present in primary key. Any value in the primary key cannot be changed by any foreign keys which refer to it. Next one is super key. Super key is the set of all keys which help to identify rows in a table uniquely. This means that all those of column of a table then capable of identifying the other columns of that table uniquely will be considered as super key. Super key is basically the superset of a candidate key. The primary key of a table is picked from the super key set to be named as the table's identity attribute. Now basically we have a candidate key. We add some modifications. Suppose our candidate key is AB and the set of relations we have A, B, C, D, E. Now, if the candidate key is AB, then the super key is A, B, C, A, B, D. These are the super keys. In this definition, this is explained. Super key is a set of keys which helps to identify rows in a table uniquely. This means that all the columns of a table then capable of identifying the other columns of the table uniquely will be considered super keys. Now the next one is candidate key. Candidate key are those keys that are uniquely identify rows of a table. The primary key of a table is selected from one of the candidate keys. Primary key of a table is selected from one of the candidate key. Suppose we have a pair of like 4 to 5 candidate key. One unique unique primary key is selected from that bunch of candidate keys. So candidate key have the same property as the primary key. There can be more than one candidate key in a table. Candidate key is always more than one, but primary key is not more than one. Primary key is always only one key. There can be more candidate key than just one for any table, but they can never be empty. Candidate key and primary key never be empty. Every candidate key carries unique information values. Beside these characteristics, a combination of attributes also work as a set of candidate key. In some tables or in some relations, we have a problem. Basically, we don't find a single unique candidate key. At that time, we combine many different keys and make one unique candidate key. The next one is alternate key. A table can have multiple choices for primary key. However, it can choose only one. So all the keys which didn't become the primary key are called alternate keys. The next one is foreign key. Now, what is foreign key? Foreign keys concept is related to primary key and candidate key. Basically, all the keys are related to each other at some extent. But in foreign key, foreign key is used to establish the relationship between two tables. Suppose we have two different tables and it helps us to establish a relationship between those two tables. A foreign key will require each value in a column or a set of columns to match the primary key of the referential table. Now I'll explain. Foreign key have to maintain the database and referential integrity. Foreign keys are essential for maintaining a difference between two entities that might be linked with the same information but do not share similar information. In such cases, tables are linked to maintaining a connection but do not entirely work as a replacement for each other. For an instance, if any individual working on the marketing department might have marketing department information in its employee table, but does not mean the table can be similar to the department table held in the marketing department. This is the example of foreign key. Now, what is composite key? Basically, composite key is a set of two or more attributes that are identify each tuple in a table uniquely. The attributes in the set may not be unique when considered separately. However, when taken all together, they will ensure uniqueness. The concatenated key is another name for a composite key. Next one is unique key. Unique key is a column or set of columns that uniquely identify each record in a table. All values will have to be unique in this key. A unique key differs from a primary key, but it can have only one null value, whereas a primary key cannot have any null value. Primary key can never be null, but unique key have only one null value. Among the 7 types of key available in the DBMS database management system, a few other types of keys in SQL are also accessible. These keys is called artificial key. An artificial has no relevance or meaning to the business, but is often used to tackle conflicting data management situations. For example, if there is no attribute that compromises all required primary key properties, or if the primary key are complex. Next one is constraints in relational model. When designing the relational model, we define some conditions which must hold for data present in the database are called constraints. These constraints are checked before performing any operation like insertion, deletion, updation, anything in the database. If there is a violation of any of the constraint, the operation will fail. Now, the first constraint is domain constraint. These are attribute level constraints. An attribute can only take values that lie inside the domain range. That is, if, for example, if a constraint age is greater than 0 is applied to student relation, inserted a negative value of age will result in failure. Suppose we have a student and we put a condition: the age of the student is greater than 0, obviously which is 0. But if negative value is put in that constraint, then it will fail. It will cause failure. Next is, first one is domain constraint, second is key integrity. The second is key integrity. Every relation in the database should have at least one set of attributes that define a tuple uniquely. Every relation in the database should have at least one set of attributes that define a tuple uniquely. Those set of attributes is called keys. Example, roll number in student is key. No two students can have the same roll number. So a key has two properties. First one is it should be unique for all tuples. Second is it cannot have null values. Third is referential integrity. When one attribute of a relation can only take values from another attributes of the same relation or any other relation is called referential integrity. Suppose we have one attribute of a relation can only take one value from another attribute of the same relation or any other relation. This is called referential integrity. Next one is anomalies in the relational model. First of all, what is an anomaly? Anomaly is basically a error or something like that. An anomaly is a irregularity or something which deviates from the expected or normal state. When designing database, we identify 3 types of anomalies: insertion anomaly, updation anomaly, and delete anomaly. Now, what is insertion anomaly? We can't insert a row in referencing relation if referencing attribute value is not present in the referenced attribute value. This is called insertion anomaly. Now, deletion and updation anomaly. We can delete or update a row from referenced relation if the value of referenced attribute is used in the value of a referencing attribute. Advantages of relational model. First of all, this is the simplest model. A relational model is simple and easy to use in comparison to other languages. Next one is it is flexible. Relational model is more flexible than any other relational model present. Overall, we have different types of models, but the relational model is most flexible model from different other models. Secure. It is secure. It is definitely more secure than others. Relational model is more secure than any other relational model. Take it, data accuracy. Data accuracy is more accurate in the relational data model. Another one is data integrity. The integrity of the data is maintained in the relational model. Operations can be applied easily. It is better to perform operations in the relational model. These are the advantages of relational model, like simple. It is simple in nature, it is flexible, it is more secure, data accuracy is much more better, data integrity, and etc. Disadvantages of relational model. Relational model is not very good for large databases. When we have large data set, then it is not good. It will fail. It will definitely fail. Sometimes it become difficult to find the relation between tables, because most of the complex structure, the response time for queries is high. Characteristics of the relational model. Data is represented in row and column called relation. Data is represented in row and column called relation. Data is stored in tables having relation between them called the relational model. The relational model support the operations like data definition, data manipulation, and transaction management. Each column has a distinct value and they are representing attributes. Each row represents a single entity. Thank you so much. This is my lecture for today.